let's look at this polynomial here. So we've been working with finding roots, and we've been doing that by factoring. When it's an intercept form, it's pretty easy, but looking at this one, we don't really have a method for factoring this. Usually when we have 4 terms, we'll try grouping. Grouping isn't going to work here. So how do we come up with a way for finding all the roots? Well, that's where we're going to use what's called the rational roots theorem. It's going to give us a list of possible values that this polynomial could have for its roots. If you remember the fundamental theorem of algebra, it just says that whatever the degree is, that's how many roots you're going to have. This is a cubic, so it has 3 roots. Now those roots could be real or imaginary. If they're real, they could be rational or irrational. If they are rational, that's where we use the rational roots theorem to test it out. We're going to be doing some practice with that today. So here is kind of what to expect. We're going to use the rational roots theorem to determine possible rational roots for a polynomial. Then we're going to test those possible rational roots using the remainder theorem. Once we've done that, we're going to use synthetic division to divide out those roots and then factor to find the remaining roots. So that's what we're going to do. Here's a little more detail in that. How the rational roots theorem works. This helps you find all possible rational roots by taking factors of the constant term and dividing them by factors of the leading coefficient. So I'm going to start with my constant term, and I'm going to look, that's going to be the last one with no x's on it. And I'm going to look at all the numbers that multiply to get that. Then I'm going to divide those factors by factors of the leading coefficient. And any of those, there's a possibility as a rational root. Now, how do we know if it's an actual root or not an actual root? We're going to use the remainder theorem. We plug in that value, and if we get 0, then we know it's a root. It divides evenly. If we get anything besides 0, then it won't work. Once we know it's a root, we're going to divide it out using synthetic division, and then we'll factor or keep using synthetic division and keep testing until we get to that point. So let's do an example. We're going to do 3 examples here, and hopefully it'll make sense the more as we go through this, okay? So let's look at this one. This is the same example we saw before. So we know that this is a cubic. So I know that the degree is 3. The way you know that is that's the highest exponent. So in standard form, the highest exponent is your degree, and here that's 3. So this tells me that there are 3 roots. Now again, those roots can be real or imaginary, and if they're real, they could be rational or irrational. The rational roots theorem only applies to those rational roots. But usually these kind of setup problems, we're not going to see those irrational ones or those imaginary ones. That'll be a future lesson. So if you remember from the previous page, what we're going to do is we're going to look at our constant term. The constant term here is 3. And the only things that multiply to give you 3 are 1 and 3. Now, we have to keep in mind that could be positive or negative, so we'll look at plus or minus 1 and 3. We're going to take those factors and divide it by factors of the leading coefficient. Well, what is the leading coefficient? If it's not showing anything, then it's 1. And the only factors of 1 are plus or minus 1. So we're going to go through and say, okay, my possible rational roots. These are just things it could be, okay? It's going to be factors of the leading coefficient, so that's plus or minus 1 and 3, divided by factors of the leading coefficient, which is 1. So again, factors of the constant term divided by factors of the leading coefficient. Now, when we divide by 1, that's pretty easy. It's just going to be plus or minus 1 or 3. So you've got 1, negative 1, 3, negative 3. So we've got 4 possibilities. Now, we know that this has 3 roots, but again, we don't know which ones are rational or irrational. And obviously 4 is greater than 3, so at least one of these is not going to work. So we're just going to guess. We're going to choose one of those and plug it in, and let's hope that it gives us 0 when we're done. I'm just looking at it, I can kind of already tell what's going to happen if I plug in 1. 1 plus 1 plus 3, and then I'll get minus 5. Got a good feeling there. So let's go with 1, okay? F of 1. I'm going to get 1 cubed plus 1 squared minus 5 times 1 plus 3. So, that's going to be 1 plus 1 plus 3, that's 5. 5 minus 5 is 0. Hey, that's what we want. What that tells us is that 1 is one of our roots of f of x. It also tells us if we were to put that into parentheses, make it look like x minus 1, this is a factor of f of x. I'll add of f of x here. So what we've done is we use a rational roots theorem to give us our possible roots, and then we use the remainder theorem to test those, and we got pretty lucky here. Our first try, we got 0. Now the question would be, what if we didn't get 0? Well, then you'd go and plug in another one, and you keep plugging them in until you get 0. We got it right off the bat. So now what we're going to do is we're going to take f of x, and we're going to divide it by the factor x minus 1. So we're pulling out that factor, because we want to find all factors. We found 1. We're going to divide it out. Now, since this is in the form x plus or minus a number, we can use synthetic division. So I'm going to use synthetic division here, where 1 is going to be our 0. It's our root. And then remember, with synthetic division, we write the leading coefficients here. I'm checking to make sure it's in standard form, making sure I'm not missing any terms, and I'm also writing all over this board. Didn't mean to do that. Let's actually, let me just undo that. Nice. That's a cool trick. Okay, so now what we're going to do, maybe, is we're going to write out those leading coefficients. So we've got 1, 1, negative 5, and 3. If you remember with synthetic division, you bring down the 1. Whatever's below the line, you times by the number up here. 1 times 1 is 1. And whatever's above the line, you add together. 1 plus 2, or 1 plus 1 is 2. 1 times 2 is 2. Negative 5 plus 2 is negative 3. And 1 times negative 3 is negative 3, which adds to 0. We knew we were going to get 0 because we already checked it using the remainder theorem. But now what we're going to do is have the quotient. So we're going to have 0 is my remainder, negative 3 is a constant, my linear term, my quadratic term. So after I divided f of x by x minus 1, what we're getting here is x squared plus x minus 3. So there's still 2 roots left in here. And we can find that by just doing some simple factoring. I forgot to write the 2, so sorry. Let me put that 2 in there. If you remember with factoring a trinomial, what I'm trying to do is to get it into parentheses like this. And the way I think about it, which is, it's different for different teachers, but the way I think about it is I say, okay, well I know that whatever these 2 numbers are, they're going to multiply to give me negative 3. So I'm going to put a negative 3 up there and say it's timesing to give me negative 3. But then they're going to add to give me a positive 2. So I have to think, what combination of factors of 3 add to 2? What multiplies to negative 3 and adds to 2? And the answer is going to be 3 and negative 1. 3 times negative 1 is negative 3. 3 minus 1 is 2. So if we do plus 3, and then we do minus 1, then we're going to get our answers there. Now, that tells us that we get a root of negative 3 and a root of 1. And so now we have all of our roots. We have a root at negative 3. We have a root at 1. And then we also have another root at 1. So that means we used 1 twice. We're going to hit the pause button there, and I'll come do the other example.